Okay, gotcha. Okay, good. All right. So where does that sit with respect to our critical value? So we're at negative 1.645. Ooh, doesn't look like we're going to reject, right? So the test statistic, remember this is where the mean is 0. Okay, we're in Z land. So if we're going into the negatives, the 1.5 is going to sit on this side of the critical value. So therefore, what's our initial conclusion?
Do not reject.
Do not reject HO. Do not reject HO. This is a close one. This is one of those that's a really close one. No, our initial conclusion will just reject or not reject. And then our final conclusion, we'll talk about what that means. Okay?
I thought. Okay, yeah. All right.
Okay, so
That's
Paul?
fine.
I have just a quick question. Why do we say do not reject? Why don't we say accept or something like that?
It means the same thing again.
Like negative, that's all. I like that
Good
better.
question.
Accept it, Joe.
Because HO is kind of being challenged. So, and it's already been established. So, yeah, accept HO, do not reject HO. I could live with that.
By not rejecting it, you're still not accepting that it's 100% accurate. You
Yeah.
can't accept it because it might be one of the...
Yeah, because you might be making an error too, right? Right, according to your sample.
Yeah.
If you just came in, there's a new quiz that you need to get, and I have your labs, so you can get those after.
That's good.
And all the keys and everything have been posted on my website. So our initial conclusion, and this is important for my online folk. Okay, this is what how I'm gonna expect you to write up the results of a hypothesis test. In the initial conclusion, and I did this in some of the examples I posted on the voice thread, I want you to either say reject or do not reject HO. It's just the way the language is done, Paul. You know.
It's fine. Don't ask.
We're going to not reject HO, and you don't have to explain to me why, because draw this out, and I can see that you figured out why, because the test statistic is in the blah 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 blah. I get it.
So we don't have to.
Okay, and then a final conclusion. What does that say about the percentage of people who eat dinner together 7 nights a week? Okay, so go back to the question. Has the proportion of families with children under the age of 18 who eat dinner together 7 nights a week decreased?
No.
So just answer that question. We did not reject HO, so it looks like the proportion of families with children under 18 who eat dinner together 7 nights a week hasn't decreased significantly. You with me? So let's go back and answer the question. The sample data, support, something like that. That the proportion of families who eat dinner together, families, kids under 18, who eat dinner together 7 nights a week, has not decreased significantly. And some of you are writing sentences that don't make sense. Go back, I mean, it's not even a complete sentence. It's not a correct sentence. So go back after you're done and read your sentence through yourselves, okay? The sample data support that the proportion of families with kids under 18 who eat dinner together 7 nights a week has not significantly decreased. Okay. You guys okay with that?
Yes.
Does this make sense?
Yes.
Let's do it by calculator. Okay, so if you're using the TI 83 or 84, you're going to want to go to the tests menu, stat, right, And then this is a one proportion z-test. This is a one proportion z-test. Chances are that it's number 5 on your menu. So under one proportion z-test, you're going to enter the P naught is the percentage in the hypotheses, okay? The X, your number of successes, and your N is the number of trials. And remember that success is relative. It's simply how many people that responded or have the attribute that you're looking for. Okay, whatever is that attribute that you're looking for. In some cases, it can be, you know, a percentage that got cancer or something. It's not necessarily a good thing, but it's what you're looking for. So again, that's one prop z-test. It's in your tests menu. You hit stat, 2 right-hand arrows. Then you're going to highlight the symbol in the alternative hypothesis. Remember, that has everything to do with how your p-value is calculated. So it's very important that that is right. Z is negative 1.44. So Ben was actually right.
Yeah.
And our result isn't quite as extreme as we thought it was. P-value, though, you can see that this is still a result that's kind of on the fence. Because the p-value, anytime the p-value is between 1 and 10%, is that strong evidence for or against HO?
No, it's not strong.
No, it's really not. It's really not. Strong evidence against HO is going to have a p-value that's less than 1%. Strong evidence for HO is going to have a p-value that's at least 10%, bigger than 10% actually. Okay, so does that make sense? So based on the p-value, would we reject or no? Your alpha is 5%, your p-value is 7%, would you reject?
No.
No, because the p-value is not smaller than the significance level, right?
Yes.
You guys with?
Yep.
Okay. Good, good. Okay, let's try another one.
Wait, can I ask a question?
Sure.
On the calculator, how do you know to use the one prop z-test? Like what signals you use that?
It's a test of proportions, and it's a test of one proportion. So let's go back to that menu. It's definitely a hypothesis test, so it's going to be something 1 through 6, right? So you want something to do with proportions. That would be selection 5 or selection 6. Selection 6 is 2 proportions, so by process of elimination, you kind of go to the one prop. And it's always a z. Remember, it's always a z for proportions. Does that make sense, Amy?
Yeah.
Good. Good. Yeah, so for, and remember, check out that flow chart that I put on my website, because it really helps you dial in exactly where you want to go. Keith?
And for our p hat, as far as rejecting HO, will that always be universal if it's under 1%? We can generally not reject.
Anytime the p-value, not p-hat.
Or p value.
Yeah, anytime the p-value is less than 1%, you're going to reject HO.
So that's anytime?
Anytime.
And then above 10%, not?
Not. Exactly. Yes. Yes, in general. And otherwise, Keith, you're gonna have to compare the p-value to the alpha. Okay? So these values that are kind of gray areas, right? It's going to be dependent on the alpha that's given. All right?
So, let's say your alpha was higher, would you still not reject it?
Okay, so let's say, gang, that we got an alpha of 10%. Remember, that's just set by the researcher. Okay? So if we got an alpha of 10%, if we got an alpha of 10%, are we still going to reject or no?
No. Yes.
Yes.
Yeah, because now the p-value is smaller. So that's why I'm saying it's on the result is not strong evidence one way or the other if you can switch your alpha and get the opposite conclusion. Does that make sense?
Say it one more time.
The test is not strong evidence for or against HO. Anytime you can switch the alpha value, because again, this is set by the researcher, and draw a different conclusion.
How do you think this?
And that's going to happen anytime the p-value is between 1 and 10%. Yeah, Mark?
How do you know to switch it to 0.10?
That was like.
We just kind of arbitrarily.
So if you switch to like 0.25? it's-
Well, your alpha, remember, typically is going to be 1%, 5%, or 10%.
Okay.
Once in a while, 2%, but not very often. Okay? Is that okay with everybody?
Do we reject it with both alphas?
No.
If it's 10%, we're going to reject. If it's 5% or 1%, we're not going to reject.
Okay, that's fine. Now, you said if the p-value instead of being 0.07 was 0.01 or less?
If it's less than 1%, you're
Yeah,
always going to
because-
reject.
Because it's gonna be outside of the alpha.
It's going to be so far into the tail.
Yeah.
It would be, in other words, it would be smaller than any reasonable alpha. Yeah. Yeah. Exactly. Exactly.
So, yeah, so, no, you've been making this point the last couple of classes about,
And it's hard to remember because you got p hat, you got p values, you got this alpha thing. What's with this alpha thing?
No, but I'm saying, like, what do you want, Is it just depends on what your employer wants? I mean.
What do you mean in terms of alpha?
No, like with the probability, and whether it's past alpha or not past alpha. Like it sounds like, because we're doing the problem right, but then you're coming to us and saying, well, that's not good enough, because if I switch it to 10%.
You're right. I mean, this is why this is so different from like algebra, where you get x equals a number. And that number works or it doesn't work, and there's no gray areas. But now there's a lot of gray areas. Yeah. There just is.
For this class, it's good to just get it right, though.
Well, you might say in your final conclusion, you might say, the sample data support that the proportion of families with kids under 18 who eat dinner together 7 nights a week is not significantly decreased. But then you might add, but this isn't a real strong conclusion.
All right, that's cool.
I would.
Yeah.
If we're told, test this at 5%, okay, I'll test it at 5%, and I can live with that. But I'm surely not going to, put my life savings on that this proportion has not significantly decreased, because it's just too close to call.
Yeah.
If this is something that is really meaningful, like a medical result or something like that, chances are they go out, get more data, come back, and see if they can get a stronger result. If not, it's just really not saying anything.
Yeah. That's good.
Yeah.
Okay.
And that's okay.
Yeah.
Okay. I want to try something else here. Yeah, I appreciate you guys ask really, really good questions, and I'm never, if maybe I sound impatient or something, I never want you to feel that way. I love your questions. They're inspirational. So keep asking questions. Okay.